One of the things about the periodic table, we just learned before that its structure has to do with the electron configuration of each element. This also then lends itself to various properties that we can discern from looking by relative positions of elements on the periodic table. We call these periodic trends, and we're going to look at 5 of them. The first is metallic character, ionization energy, atomic size, ionic size, and electronegativity. Now, metallic character has to do with an element's luster, conductivity, malleability, all those properties that make it very metallic. So we find that we know that the left side is highly metallic, the right side are the nonmetals, in between we've got the metalloids along the staircase here. So anyway, obviously the most metallic is going to be in opposite corner from the least metallic. So down here in the lower right hand corner we have highest metallic character. So if an element is below or to the left, it will be more metallic than an element that's above it or to the right. Ionization energy is the energy required to remove an electron from the element. Over here we have single electrons. These are all S1s, all by itself. That one electron is shielded by all the others and therefore is easily removed because it's like one lone antelope being chased down by a pack of lions. The bigger that atom is, the further away that electron is and less pull there is from the nucleus. So therefore your more reactive ones and your lowest ionization energies tend to be down here. So if the lowest ionization energies are down here, the highest ionization energies are going to be up here. So therefore, the ionization energy goes up as you go to the right and go upward. And therefore, any element will have a higher ionization energy than the element to its left or the element that's below it. Atomic size relates to the diameter of the atom. Like we were saying, the outside electron of these metals over here is not pulled very tightly. There's not a whole lot of pull on it because of the other electrons inside shielding. So therefore, it tends to be far away. So therefore, because it's far away, the atom is bigger. So therefore, our largest atoms are down in this corner, and our smallest atoms are over on the upper right-hand side. The reason for this is because these are pulled tighter. These are a little bit looser. Now, that's a little bit different from ionic size, because here as we remove electrons from the outside, the nucleus is really more positive, has one more proton than electron, so it pulls the electrons in tighter. As we know, these guys are usually like a +1 ion. This guy's a +2, which means it loses 2 electrons. So the nucleus has 2 more protons than electrons, which squeezes it even tighter. So cation size goes down as we go to the left. The other way, these guys, they add electrons, -1, -2. As they add electrons, they get bigger. So therefore, I shouldn't say that. Ooh, ionic size goes this way. Decreasing ionic size this way. So therefore, the ions get smaller as we move from left to right because there are more protons pulling than electrons are present. So therefore, it doesn't shrink. So it shrinks a great deal more as we move to the right. So cations decrease going to the left, anions decrease going to the right. And the last piece is electronegativity, which is the tendency to attract electrons. The most electronegative elements are up here in this corner. So therefore, this corner is most electronegative, this corner least electronegative. So that's what we know about periodic trends and how the modern atomic theory plays into that.